Okay, look at the buff packet, please. Okay, my recommendation is to take all of your Unit 3 material and just leave it at home, and that way your binder's not so heavy. Pass out all the packets for Unit 4. Listen, Unit 4 is all written. You won't see multiple choice. Well, there might be a few in the homework, but the test is strictly written. No multiple choice on Unit 4. Also, Unit 4 is all calculator allowed. So that's why I had to bring your calculator. So if you have your calculator, I'll pay you the ticket, I promise now. So let's do that real quick. Okay, buff packet is what we're working on today. The buff packet. Oh, I thought you did. My apologies. So the buff packet, first page talks about, says you have an airplane. The airplane is flying in a straight line. The table that you see simply records the velocity of the plane at different times. So that's where we'll start our study. Item A on the page is really simple. It says the symbol S of 0 represents what? And what S of 0 represents is the position of the plane at time 0. That's the answer to the first question. That's just review from Unit 1. So S of 0 is the position of the plane at time 0. S of 0 is the position of the plane at time 0. Then it says B, what is S of 40? Same idea, position of the plane at time 40. Questions so far on those two review items talking about position? Okay, next one says that they tell you the position of the plane at time 0 happens to be location 10. So this picture on the board here is a little bit fouled up. So at time 0, the position of the plane is 10. And then they tell you that at time 40, the position of the plane is 245. So over here, 245 at time 40. If you subtract those two positions, again, this board's kind of messed up, you get 235. 235 is the displacement of the plane for the time period 0 to 40 minutes. So you do need to memorize that word. Displacement. Questions? Okay, sometimes it's actually easier to memorize a word if you memorize another associated word. It's not the opposite, but they're related. So the other word you got to memorize is, I guess it's 3 words, total distance traveled. So we have displacement. We also have total distance traveled. So I'm going to do a slightly different example here. I will be the plane. I'll say that I still start here at location 10, but then for some reason I go the wrong direction. Let's say I go this way until I get all the way to location -20. Then I realize I'm going the wrong direction. So I go back, and now I go all the way to location 245. Okay, this is not a trick question. I just want to make sure you're following along. In the second example, raise your hand. Don't say it out loud. What was the plane's displacement? Displacement simply asks, how different is one position from another? So in the first example, the plane started at location 10, ended up at location 245, so the displacement was 235 miles. In the second example, the plane started at location 10, went to location -20, and then from -20 the plane went all the way to 245. So if it feels like a trick, you figured it out. What is the displacement in the second example? It's not meant to be hard, just trying to make sure you're following along. Kate?
Is it still 235?
How many knew that? 2 points, perfect. Still 235. 3 for Kate. Displacement simply refers to how different is one position from another. So it didn't matter that the plane went the wrong way for a while. Ultimately, the plane was still 235 away from where it started. That's displacement. Questions? Okay, raise your hand again. What was the total distance traveled in the second example? In the first example, the total distance traveled was 235 because the plane went from location 10 straight to location 245. In the second example, what was the total distance traveled? Hands up. Come on. Total distance traveled, Josh, in the second one. Say it loud. 265. Close. Let me talk you through it. So we were at 10. We went to negative 20. So how much have we traveled so far, Josh? Good. Now we go all the way from negative 20. So we went. So what is the total? There we go. So 3 points for Josh. Please raise your hand if you knew that the total distance traveled was 295 in that second example. 2 points. Questions? Okay, test 4, you'll definitely be tested on both items, displacement and total distance traveled. So, please.
Wait, from 10 to negative 20, wouldn't that be 30?
So that was 30 for this part of the journey.
Yeah, and then plus another 30, and then plus another.
There we go. So 30 to get back to here. So 60 plus 235, 295. Good job. 2 for Sabrina. Anyone else? Okay, cool. To give another example, nothing fancy here, it says time equal 20. The position of the plane is 152. Hands up, what goes in the blank? Hands up. So item D, what's the answer? Hands, everybody. Waiting. You can do the math in your head or grab your calculator, it doesn't matter. A few more hands would be good. A couple more. Let's go, Caleb.
93.
Raise your hand if you had 93 before Caleb said it. 2 points, 3 for Caleb. Questions? Raise your hand if you know the answer to E. Hands up. Item E. Item E is talking about velocity. So now you must use the table on page 1, because the table on page 1 gives several velocities. So item E, what's the answer to item E? Hoping for a few more. There we go. Let's go, Charity.
Would it be 0.3?
Please raise your hand if you knew the answer to be 0.3 before Charity stated the answer. 2 points, 3 for Charity. So up here it says, at time equals 0 minutes, the velocity of the plane is 7 miles per minute. And then we now investigate the velocity at time 40. We pay no attention to what the velocity was in between. So at time 40, the velocity is now 0.3 more than it was. So that change in the velocity is a positive 0.3. Questions? Okay. Yeah, please.
Do you want to state that it's positive or negative?
Oh, you don't have to. I just wanted to emphasize. You do have to know which one it is. Like if it's negative, you have to reflect negative. 2 for 100. Next page. Go to page 2. Okay, they tell us that at time 10, the position is 97. So we know that from time 0 to time 10, hands up, what goes in this blank? What is the displacement from time 0 to time 10? Hands up. What is the displacement from time 0 to time 10? There we go, let's go Jason.
87.
So raise your hand if you knew the answer to be 87 miles. 2 more, 3 for Jason. So he's taking the fact that they gave us on the previous page where they said the position at time 0 is 10, and now the position at time 10 is 97. So the difference between those two positions is 87 miles. Questions? Okay, to be honest, on the AP test, they will rarely ask you that kind of a question, but you have to understand that idea to understand the next idea. So instead of using position to find displacement, what they more likely will test you on is how do you use velocity, right here, velocity, to find displacement. And it's actually a really simple computation. You simply say, well, at time 0, according to this chart, the plane has a velocity of 7 miles per minute. So that means every time 1 minute of time elapses, the plane moves 7 miles. The plane's position changes by 7 miles. So if that happens over and over again for, I don't know, 10 minutes, I could make an estimate that the plane's position changed by 70 miles in that 10-minute period. Questions? Please.
But you also have to do like, it's only going, the velocity is only set for like 0 to 4. So you have to do like from 5 to 9 through the velocity.
So 3 points for Jesse. I could say that's probably not the best estimate because, as Jesse said, the velocity of the plane really wasn't 7 miles per minute for all 10 minutes. So maybe what I do instead is this. I say, let's go 7 miles per minute. Let's assume that the plane only has that velocity for the first 5 minutes of time. And then, so that would be a total of 35 miles in those 5 minutes. And then, for the next 5 minutes, let's assume the velocity is 9.2 miles per minute. And the plane has that velocity for another 5 minutes. That would be a total of 46 miles. So that would give me, let's see, 81. Questions? Please.
So that's just like an estimate, but to find the exact displacement, should we do integral from 0 to 10?
So 3 points for gold, and you're heading exactly in the right direction. Hold that thought for just a minute, but you're heading exactly in the right direction. Other questions? Okay, cool. Oh, please.
Are they both acceptable answers for that kind of question for estimation?
They're both acceptable estimates. 2 for Dylan. Hands up. Which estimate is better? Hands up. Hands up. Which estimate is better? Which is better, Jack?
Purple estimate.
And why?
It gets closer as much as it.
Yeah, here we're assuming the plane has a velocity of 7 miles per minute for an entire 10-minute period. But then we say, no, not really. Would be better to assume that the plane has a velocity of 7 miles per minute for only 5 minutes, and then the plane has a velocity of 9.2 miles per minute for the next 5 minutes. That's a better estimate. 2 points if you knew that, 3 for Drex. Ian?
As long as you think the purple is better, if you did the green, would that be wrong?
No, not really. What they'll do in the AP test is they're going to give us a little bit more information.
Okay.
So they'll guide you as to kind of what kind of estimate they want.
Okay.
Does that help?
Yeah.
Yeah, 2 more. Anybody else? Please.
Like, how would that not be wrong? Because we know that it changes once it hits 5 minutes. How would it not be wrong to say it stays at 7 miles per minute and 10 miles?
3 points for Jackson. The reason is we don't even know that the plane has a velocity of 7 miles per minute for the first 5 minutes at all. All we really know is that at time 0, the plane has a velocity of 7 miles per minute. The plane could have changed its velocity a lot during this 5-minute period. So that's why our estimate could be okay, but it could be quite bad because we don't know what's happening in between. So really, you have no way to know whether this estimate or this estimate is actually better because there's so much data you don't have, if that makes sense. But as I said to Ian, for a test question, they're not going to leave you kind of struggling with like, well, how, what kind of estimate I'm supposed to make. They're going to give more guidance to what kind of estimate to make. So, everybody raise your hand and answer this. What information do we need to truly make a better estimate? Ends up, like we don't have enough information to make a very good estimate. What information would we need to make a very good estimate as to how much the plane's position changes? What is the displacement of the plane for this 10-minute time period? We've done a green estimate, we've done a purple estimate. I just told you neither one is necessarily very good. And I gave the reason why that is so. I said this because this is talking about 2 velocities in a time of 10 minutes. The velocity could have been all kinds of different things in those 10 minutes. So what do we need to get a very, very good estimate? Let's go, Sam. Yeah, we need the velocity frequently. If we knew the velocity like at every moment in time, like every second, we could do this type of a computation. We would say, oh, the velocity is whatever for 1 second. And then the velocity is something else for the next second, something else for the next second. If we did that, we get a pretty good estimate because we're checking the velocity so frequently. If you had your hand raised, give yourself 2. Sam gets 3. Questions? Okay, that's where we're headed, is this idea of, hey, we can find displacement, it just depends on how often we check the velocity. So here's what, go to number 3 now, page 3. This is what Golden was talking about. Brand new symbol for many of you. New name for most of you. We're going to talk about what we mean by a left Riemann sum with 4 subintervals of equal length to estimate the value of this integral. Okay, this brand new symbol starts with this symbol here. If you memorize where the symbol comes from, the math is easier. This is an S. It stands for the word sum, like to add things up. When you do an integration, you're always summing. We're going to sum from time equals 0 to time equal 40. And now the symbols tell us what we are going to sum. We're going to sum up a bunch of products. Product means multiplication. So we're going to take a velocity. We're going to multiply that velocity by some change in time. And after we've done that over and over again, we're going to sum up all of those products. It's exactly what we did here. That's why Golden recognized it as an integral. We took a velocity, we multiplied by a change in time. We took another velocity, we multiplied by another change in time. That gave us 2 products. We then took those two products and we summed them together. That's what integration is. Questions? Cool. So back to page 3. This is the part I told Ian. They're going to give you specifically how they want you to make the estimate. So because we are taking velocity and we're multiplying by change in time, we are finding displacement. That's the most important part of what I'm showing you. The computations are super simple. You can learn them super fast. The key thing is to recognize what you're computing. You're taking a velocity and you're multiplying by a change in time, so you're finding a displacement. That's what we're going to do here as well. Velocity multiplied by change in time to calculate displacement. We're supposed to do it for a 40-minute time period, but we're supposed to break up the 40 minutes into 4 subintervals of equal length. So I'd like everyone to raise their hand now. I want to break up the time period and don't overthink it. If I have 40 minutes of time, I'm supposed to break that into 4 subintervals of equal length. Hands up. How long is each time period? There we go. So how long is each time period, Maddie? Say again.
10 minutes.
So each time period is 10 minutes. If you knew that, 2 points. Maddie gets 3. So Maddie, where would the first time period begin? At what time?
0 to 10.
Perfect. 2 more. Look at me. When you mark the table, please mark it exactly as I mark it. I've seen students do it in different ways, and it usually leads to errors. So just say how we're starting at time 0. We go all the way to time 10. Then Anna, what would be the next time period?
From 10 to 20.
Perfect. So we draw another little bracket from 10 to 20, 2 points for Anna. And then just keep following that pattern. So then we would have 20 to 30. And finally we would have 30 to 40. So we've broken up the 40-minute time interval as they specified. Like I said to Ian, they're telling us how to make the estimate. So, questions? Awesome. Now you just follow the symbol. It says we're supposed to take velocity multiplied by change in time. Well, for every single subinterval, time is changing by 10 minutes. So for this example, our estimate of dt is going to be 10 minutes. dt is really infinitesimal in length, but we're just doing an estimate. So we're saying, well, we'll estimate dt to be 10 minutes. We're supposed to multiply dt by a velocity. So we'll go to Maddox here. Left Riemann sum, 4 subintervals of equal length. Integration means multiply first, then add up. So I go to my first subinterval in blue. Within that subinterval, there are many, many velocities, but I only know 3 of them. So I'm supposed to use one of them as my estimate for the velocity during those entire 10 minutes. It says left Riemann sum, so what velocity, Maddox, would you guess they want us to use?
7?
Because it is most left. It really is that simple. That makes sense? 2 more. So you take, now don't put equal. We're not doing an exact computation here. We're estimating. The integral is only exact if we make dt infinitesimal in length. So we're estimating. We take a velocity of 7 miles per minute. And we multiply by a dt of 5 minutes. No, sorry, 10 minutes, my bad. That means for those first 10 minutes, we are estimating a displacement of 70 miles for those first 10 minutes. Questions? So Mary, what would you have me write next?
I'd do the next 10 interval. I guess that's the next interval of 10, which would be from 10 to 20.
Pause for a minute, doing great. So we've got our first product right here. We now need our second product. We're going to sum them together. So Mary correctly went to the second subinterval. Because we've already figured out the displacement of the plane for the first 10 minutes, at least our estimate of that displacement is 70 miles. So we're good there. We'll go to Brooklyn now. So in that 10-minute period, Brooklyn, we're supposed to take a velocity, we're supposed to multiply by a change in time for that subinterval. So what velocity, Brooklyn, do you want me to pick?
We use 9.5.
We use 9.5 because that is the velocity at the leftmost time of that second subinterval. 2 points for Brooklyn. And we take that velocity. You can stop writing units. That gets a little bit tedious. Multiply that by the 10 minutes. We now know that the displacement for the second 10-minute period would be an estimate of 95 miles. Questions from anyone? Well, so Jessica, what would we do next?
Then you're gonna do left, or you're gonna do, the left-hand sums of 2, or 1.5 times by 10.
2 more points. Questions? And then Ethan, then what?
Which Ethan?
Sorry, my bad.
You're gonna take the interval, the last interval, and do 2.4 times 10.
Points. And if I didn't add them up wrong, my little key there tells me that that goes to 234.
If I take 2pi over 3, subtract by 2pi, get a common denominator.
Again, not a perfect estimate because we only checked the velocity 4 times in 40 minutes, but that's how they specify to make the estimates. Question? Extremely common question on the AP test. Every single year has 2 or 3 of these. Every single year. So. Cool. And to get a better estimate, we would need to check the velocity more frequently. That's another big idea. Okay? That pretty good? Item B says we're supposed to graph, like not graph, but we're supposed to illustrate what that looks like. Here's what that looks like. 7 miles per minute is the length of this blue line. 10 minutes is the length of this yellow line. Any questions about that? If you take the 7 times the 10, you're computing an area of a rectangle. You're computing the area of this blue rectangle. So that area there is 70. If we check the velocity more frequently, we would get a slightly different picture because we would take like the 7 miles per minute for a very short amount of time. And then we would check the next velocity, something like this. And we would check the next velocity, something like this. We would get a better estimate. If we could check the velocity, at every single moment in time, we would be finding that we would get a whole bunch of rectangles whose areas all added together would end up looking something like this. We'd get a bunch of rectangles that were very narrow. Get it to work. And like a rectangle there. We would get a rectangle here. And we would get very, very close to filling the space between the velocity curve and the x-axis. Something like that. So, questions? Cool. If we keep drawing the picture, the green one would look like this. We say 9.5 is this length. So 9.5 goes to here. Meant that to be green. So 9.5 is here. Then we have our 10 minutes of time. So then we get this box. Okay, so the 70 was represented by this box. So just say it out loud together. Is the 70 an underestimate or overestimate? Say it. Yeah, the 70 is an underestimate. The plane actually did travel. The displacement of the plane was more than 70 for that first 10 minutes. Our estimate is too low. The purple, however, which was meant to be green, sorry, the purple estimate is too high. You can see from the graph. The green estimate's too much. Questions? Cool. And then you just, so that would be this one here, sorry, green one. So that estimate's too much. You go to the brown, 45 miles. Let's see, that's going to be here. That one's a little hard to tell. It's too far. That one's definitely an overestimate also. Not as hard as I thought. Questions? Please, Sabrina.
It's really obvious, but I'm just not really know. But why did you do 9.5 after 7 miles? Like, why would you just do that on velocity?
The 9.5 here.
Yeah.
So what I did is I went to the first 10-minute period. So that's right here. And I said for those entire 10 minutes, we're going to assume that the plane always has a velocity of 7, because 7 is the velocity at the leftmost time of that time period. So that's where this came from. Then we go to the next 10 minutes, and we say, okay, so now what happened during the next 10 minutes? During these 10 minutes, we're going to assume the velocity was always the leftmost velocity in those 10 minutes. Is that your question? Two more. Anybody else? Next one, go to page 4. Okay, page 4 says use a right Riemann sum with 4 subintervals of equal length. Oh, warning. Test 4 is written. A guaranteed way to lose points on a written test is to not write integrals when you're calculating integrals. Same thing when we did derivatives. You got to write down the derivative that you're calculating. So they're going to ask us to estimate that integral right here. So make sure you write that first on your paper before you write anything else. Questions? Sweet. Now we write approximate. Go to Lexi. We now go over here to the table, Lexi, and we're supposed to do an integral calculation of velocity multiplied by change in time. So here's our table of velocity again. This is not a trick question. I just want to make sure we're all seeing it. I'm supposed to go from time 0 to 40. I'm supposed to use 4 subintervals of equal length. So what do I draw over here, Lexi?
You would go from 0, is it 7.0 to 9.5, right? You're doing subintervals?
Oh yeah, best way to talk about subintervals is always in terms
Okay,
of
so
time.
go from 0 to 10.
Yeah, we just go from time 0 to time 10. And hey, again, warning, I've seen people do this, always causes trouble. They'll say, oh, I'm supposed to go from time 0, and they draw a line like this. Don't do that. Because then they draw a line here, and then they're like, now what do I do? I guess I can draw a line here, and then they go, that's only 3 subintervals. How am I supposed to get 4? They're just thinking of it completely wrong. So if you draw the brackets, that error never occurs. So where's the second set of brackets, Lexi?
From 10 to 20.
Perfect. And so on. So 2 for Lexi. Questions from anyone? Cool. So back to Ethan Valletta. So all you do is follow the symbol. We've worked out the time part here. We've done what Ian, I keep referencing Ian's question. 2 more for Ian. We've got our 4 subintervals. We're supposed to go do a velocity multiplied by change in time for each subinterval. So Ethan, what's our estimate for dt for this computation? 10. We're saying dt is ideally 0.000 forever 1. But for our estimate, we'll just say it's 10. Okay. 2 points for Ethan. Sabrina, I've got to take a velocity and multiply by that 10. So I'm doing a right Riemann sum this time. So I go to the first subinterval. I'm still looking at the first 10 minutes. But in those first 10 minutes, I'm supposed to pick the velocity that is most right in that subinterval. There we go. So I pick 9.2. That's the velocity that's most right in the subinterval. And now you are assuming that that is the velocity of the plane for the entire 10 minutes of the subinterval. Oh, 9.5, thank you. How many saw the mistake? 2 points. So we look at the first 10 minutes, and in those first 10 minutes, we actually see 3 different velocities. 7, 9.2, and 9.5. But 9.5 is the velocity that is most right, because it's the very rightmost time. 2 more for Sabrina. So we get 9.5 multiplied by 10. So our estimate is that would be, let's see, 95 miles in those first 10 minutes. We draw a picture of that. We'd say, okay, we've got our first 10 minutes. And now the rectangular height is based on the right side of the subinterval. The 95 is definitely too high. Definitely an overestimate. Question? Piece of cake. Let's go to Riley. What would you write next, Riley?
I do 4.5 times 10.
And then those two get summed together, because that's what integration means, is to multiply first and then sum. So Riley says, okay, we take the velocities in the second subinterval, we pick the velocity that is most right in that subinterval. We'll stop writing units, that gets a little tedious. dt is still 10 minutes, so 3 points for Riley. So in that subinterval time, we assume the plane had a displacement of 45 miles. Questions? I'm bothered by anything. Claire, what's next?
On to the next section. 2.4.
There we go, 2 points for Claire. And Haley, what's the next one? 2 points for Haley. Questions? Please.
Yeah, so in the instructions, it says it includes correct units. So how do we know where we have the right units to make sure we don't lose any points? Is it only the answer?
Only the final answer.
Okay, awesome.
The 3 points for a great question. I write units along the way just as a check, because what I notice is this. If I take 9.5 miles per minute and I multiply by 10 minutes, the minutes divide out, which is what I want, because I want my final answer to be just displacement, and that's what my final answer will be, simply in miles. Okay, on the test, again, if you don't write an integral, you likely will lose a point. If they say include units, this one, look, if they say include units and you don't, they will take away a point. There's no mercy. It's like you either have them or you don't, and they must be correct. Question?
Do you have to have them on every single, like,
Step along the way?
yeah?
No, like Carrie Ann said too for Ethan. All you need to do is make sure your final answer has the correct units.
Is that, what do they mean by include correct units? Or
That's what this means. Yeah. Is make sure your final answer has the right numeric value and the right units.
So I have another question.
Yeah, please.
Do you add the means from the right Ryman and the left Ryman to get an average of what the displacement would be?
So listen up. Hey, 3 for Ethan. Listen close. If you take the left Riemann sum, which we got 237,
Yeah.
as long as the subintervals are the same and everything,
Yeah.
and you add that to the right Riemann sum, which we calculated to be 234, and you divide that by 2, you get what is known as the trapezoidal Riemann sum.
Okay.
Yeah. And they do test you on that at times as well. It's a good call. There's another way to do the trapezoidal. I'll show you that as well, Ethan, but you can really pick either method. So, questions? There's 4 types: left, right, midpoint, trapezoidal. Jackson?
Is there like a reason other than like it telling us why we would use right or left?
In a real life situation, okay, it's like, look, everybody look at me, look. In school, okay, just comparing like what I did in school versus what I did in work, everything is like tiny. Because you have to somehow find something that somebody can do in like an hour. Versus at work, you're gonna spend months accomplishing a task. So it's much bigger. But it's a great question. In a work situation, like when I worked for Exxon, a long time ago, they had a huge, gigantic mainframe computer. We've kind of gone away from that, more of like server racks now and lots of PCs all working together. But the mainframe was such that you could not occupy too much of its time because it was very expensive. And so if you had to estimate something, you had to make a good choice as to what would be the best method. And depending on the data you're dealing with, one of those 4 types might be the best method. Or to be fair, there are other methods as well, we just don't learn them. So I think they test you on 4 different types, mostly to see if you really understand what it means. And to, again, prevent you from just memorizing one procedure. They give you 4 different kinds. It's easier to memorize if you understand how it works, that's all. So they usually won't test you on all 4 types, they'll just pick like one of the 4. Does that make sense? Anybody else? Cool. Oh, please.
So there's the left, mid, right, and then there's the trapezoidal. Trapezoidal is the left and right. Mean,
Average,
right,
yeah.
average. So what about the midpoint? Do you not average that at all for the trapezoidal?
No, the midpoint, I'll show you that in a minute. Midpoint is really simple though, like Jacob, we did a left Riemann sum for this first subinterval, right?
Mm-hmm.
And so which velocity did we pick?
7.
Right, because 7 is the leftmost velocity. Jacob, when we did the right Riemann sum, we picked?
9.5.
To the midpoint Riemann sum, we're going to pick
9.2.
9.2. That's it. That makes sense.
I was just
Oh,
wondering,
sorry.
like for the trapezoidal, you just take the left and right and you just leave the midpoint out. Does that not factor into the mean? of that
Correct.
wall?
That's very good.
Okay.
For trapezoidal, you're only paying attention to the leftmost and rightmost. It's just how it's defined. There could be another method where you would pay attention to all three. We just don't use that method.
Okay.
So, does that help?
Yeah.
Come on. Cool. All right, to draw the picture, same thing again. If I went to the second subinterval, I would go to the 44.5, which means I'm going to here. So that second one is definitely an underestimate. This 45-mile displacement was an underestimate for those 10 minutes. Questions? Next one. Okay, the formula you see on the page, I can't remember what it says on the actual document. Hold on. Okay, on your paper you have what's known as the fundamental theorem of calculus. The fundamental theorem, so I've got this formula here, but you have this one written down. Your formula says the integral from time 0 to time 40 of velocity is the same thing as the position at time 40 subtract the position at time 0. Okay, please keep the two sides separate in your mind. It's not saying one thing becomes another. They're saying they're the same thing. And you can use the formula any way that you like. We talked about this today. We said we can calculate displacement by paying attention to position. That's the easy way to calculate displacement. The more complicated way is we can integrate velocity. But both methods find displacement. That's why there's an equal sign. Both methods find displacement. Question? Okay, on the AP test, there's no formula more important than the one you just saw here. None. Like I counted the entire test one time and it looked like about 30% of the questions could not be answered if you did not understand this. 30% of the AP test cannot be answered if you don't understand that one formula. Hence the name, fundamental theorem of calculus. So that one has to be memorized. You have to be good at using it. They'll ask you to use it in a lot of different ways. On this worksheet, I right away say, well, let's use the formula. Let's rearrange it a little bit so that we're actually using it to find a position. So if I want the position at time 40, the idea is pretty simple. If I want the position at time 40, well, if I know where I am at time 0, in the example we've been doing, we said that the position at time 0 was 10. So we said the position at time 0 is 10, so if I know that, and then I calculate for the next 40 minutes, for the next 40 minutes, how much is my position going to change? That's what the integral does. So if I go calculate my displacement for the next 40 minutes, that turns out to be 235. By adding those two together, I can calculate what my new position is. So that's one of the most common ways the fundamental theorem is used, is to calculate a specific position. That's the fundamental theorem of calculus. Questions? Please go.
Does that only work when the intervals are, when the subintervals are infinitesimal? Because otherwise it would be an estimation.
3 points for that. So if I can get subintervals that are infinitesimal in length, and I can use every single velocity that I can possibly measure, then it's perfect. Otherwise, we just say it's an approximation of the position. Like that. It's perfect. Anybody else?
Please, Hunter, wait, where did the 235 come from? Because wasn't it 234 and 237?
So earlier in the page, if you remember, like way back, like page 1 or 2, I can't remember, they said that we'll just tell you the position at time 0 is going to be 10.
Oh, wait, yeah.
No worries, it's a good question. And then later it said, hey, the position at time 40 is going to be 245. So what I was saying is that, like Dylan said, if we could calculate the integral perfectly, the integral would have come out to be 235. Yeah, no, it's perfect. 2 more. Yeah. Sweet. So let's use that now. So it says rearrange the FTC. So this one you would rearrange like so. S of 0 is going to equal, let's see, we'd get this. We'd get S of 40 minus the displacement. So we want to find out where we were when this all began. We've got to say, where are we now? And let's subtract from that how much our position changed. Question? So you typically will use the fundamental theorem 3 different ways. You can use the fundamental theorem as it is originally written to calculate displacement, or you can rearrange the fundamental theorem to calculate where the particle is located either at the beginning of the time period or the end of the time period, as long as you know one or the other. So. Questions? Okay, cool. Item B. So item B says, use a right Riemann sum. Riemann sum is a way to approximate an integral. So I would ignore that part for a minute, and I go right to here. What do they want us to approximate? They want us to approximate this integral. So we have to write down the integral so we don't lose points. And we are approximating the integral, so we do approximation. We're doing a right Riemann sum. 3 subintervals this time. They are to be equal in length. So Connor, let's go to the table first. What would you have me draw on the table?
A bracket from 20 to 25.
2 points for Connor. Anna, where's the next bracket?
From 25 to 30.
2 points for Anna. And Stella, where's the last bracket?
30 to 35.
So now we've covered the time period they specified. We've gone from 20 to 35. We have our 3 subintervals. They are of equal length. Everything's looking great. Questions? So Jack, what number do I write first here on the board then? Because I'm doing the integral, which means I've got to do my product first. I've got to multiply my velocity by my change in time. And we're just doing an estimate. So what do I write first, Jack?
2.4 times 5.
So I go to the first subinterval in green. In that subinterval, there are 2 velocities. Jack correctly chose the rightmost velocity. And then what's the dt, Jack?
5.
2 points. And again, the minutes divide out, which is what we want. So I know I've got the right units here. I can't do that one in my head. 25 would be 12, yeah? So the displacement for the first 5 minutes is 12 miles. Questions? So Jesse, what's the second thing I write? Yeah, you're good, sorry.
Outside. 2.4 miles. Yeah,
So I pick the rightmost, which is 2.4. Miles per minute multiplied by,
5.
perfect, 2 points. Oops, I wrote that in the wrong place, sorry. So 2.4 times 5, which is again another 12. Questions about anything? So Mary, then what?
Then you're gonna add 4.3 miles.
Miles per minute,
Times 5.
2 points. $43, half of that's 21.5. Cheat and look at the answer, 45.5. That's a terrible miles. Yeah, make sure your final answer has the units, otherwise you do lose a point. Questions? If it seems easy, that's good, because it's not really meant to be hard. Please.
Will we ever be asked to find a middle agreement sum if we have like an interval like that?
Oh, gotcha, yeah, perfect question. Everybody listen, hey, 3 for Ethan. Look, if they ask for a midpoint Riemann sum and they define intervals like Ethan said where there is no clear midpoint displayed, like they don't ever do that. They never have, they never will. They expect to, if they want midpoint sum, they give you an interval where you can see the midpoint. That's a good question. Anybody else? Cool. Item C says use the graph to illustrate, so that's easy. Just come over here and say, well, let's see, the 10 minutes, that's from 20 to 25. So there's my time period. In those 10 minutes, I'm looking at the rightmost velocity, which means I'm looking at that height there. So that first computation is a very definite underestimate. For the purple, go to the second time period. Again, I go to the right. That one's an overestimate. Questions? Please, Jason.
We actually need to know if it's over or under.
Oh, good question. Hey, 3 points. Listen, listen, listen. Everybody. They, I've seen cases where they'll do it on the same question, where they'll ask you to compute something like this. And yeah, they'll just say in the very next part, is that an under or overestimate? And so the best way to figure out under or overestimate is by just drawing a quick sketch. Like for the first subinterval, Jason, is the underestimate by a lot or by a little? The perfect answer for this subinterval here would have been all of this area here. So we're under by a decent amount. Is that fair? The second one is over. Which is worse, the purple overestimate or the green underestimate?
The green.
Yeah, the green under is worse. So far, if you're just looking at the first two subintervals, we are definitely under. Does that make sense? If I go to the third one, yeah, they'll ask it for sure. So I come over here. Now I'm kind of, kind of uncertain now, to be fair. They won't give you something like that that's hard to judge. Oh, hey, listen, please. Nobody go, listen. You don't need to do any homework tonight. Just bring the book, pack it back. We'll work on it again on Wednesday. So you don't have to do anything tonight. Just bring it back. Just stop the video.